In the grand story of modern medicine, there are some real unsung heroes working behind the scenes. And today, we're going to focus on one of them, an invisible force that truly makes modern surgery possible. So let's get into it. Let's dive into the story of Sevoflurane.
Have you ever had surgery? You probably know the drill, right? The anesthesiologist tells you to count backward from 10, and you're lucky if you even make it to 9. So what is that magic that works so incredibly fast and so gently?
Well, the answer in millions and millions of cases all over the world is this molecule right here, sevoflurane. It's one of the most widely used anesthetics today, and for a very, very good reason. So we're going to break down exactly what it is, how it works, and why it's become such a cornerstone of the modern operating room.
All right, so let's get formally introduced. Since it came on the scene in the 1990s, sevoflurane has become a real go-to choice, especially for outpatient procedures. And, as we're going to see, it plays a super important role when it comes to pediatric anesthesia. Okay, so scientifically speaking, it's called a halogenated ether. Big words, I know. But for us, just think of it as this highly specialized vapor. It's designed to do one thing exceptionally well, to safely guide a patient into and then back out of that state of general anesthesia. So what makes it so special? Well, it's all about its physical properties. It's a clear liquid, it's not flammable, that's great. But the crucial points here are mild, pleasant odor, and non-irritating. Now, this is a total game changer, especially for children who might be scared of needles. They can just breathe the gas through a mask and gently drift off to sleep, no injection needed to get things started. And that brings us to sevoflurane's real superpower. It's incredible speed. This is what allows you to go from completely awake to completely under in just a matter of breaths. And it all boils down to one single crucial number. Now, that number is determined by something called the blood/gas partition coefficient. It sounds super complicated, but the concept is actually really simple. It just measures how much the gas wants to hang around in the blood versus how quickly it wants to move on to the brain. A low number means the gas isn't sticky. It doesn't linger in the blood. It just races straight to the brain to do its job. So the main thing to remember is lower is faster. And sevoflurane's number? It's an incredibly low 0.65. That right there, that's the secret sauce. This little number is why you go under so remarkably quickly, and as we're about to see, it's also why waking up is just as fast. You can really think of it like having an easy pass for your body. The gas gets inhaled into your lungs, but because that coefficient number is so low, it doesn't get stuck in traffic in your bloodstream. Nope, it just sips right through the toll booth of your lungs, gets to its destination, the brain, and starts working immediately. And then, when the surgery's over, it takes that same express lane right back out of the body, which leads to a quick and much more clear-headed recovery. Okay, so we know it gets to the brain fast. That's clear. But what does it actually do once it gets there? How does it flip that switch in your brain from being conscious to unconscious? Well, it's basically a brilliant two-pronged attack. On one side, sevoflurane boosts the brain's calm-down signals. It does this by supercharging a neurotransmitter called GABA. It's kind of like turning the volume way, way down on all your brain activity. At the exact same time, it blocks the wake-up signals by jamming up something called NMDA receptors. So you see, it's not just putting you to sleep, it's actively stopping your brain from waking itself up. And the results of this 1-2 punch is the complete state of general anesthesia. And this isn't just about being unconscious, it's the whole shebang. It includes amnesia, so you don't form any memories, analgesia, so you feel zero pain, and immobility from muscle relaxation, which allows the surgical team to work safely. But sevoflurane doesn't just go to work on the brain. So let's take a quick tour of what it's doing throughout the rest of the body, because these are the effects that anesthesiologists have to manage very carefully during any procedure. First off, how does it leave your system? This is pretty incredible. Over 95% of the drug is eliminated completely unchanged, just by you breathing it out. This is a huge reason why recovery is so fast. Your body doesn't really have to do much work to get rid of it. Only a tiny fraction, about 5%, gets processed by your liver. Now, one of its most important effects is actually on your respiratory system. It's a potent bronchodilator, which is just a fancy way of saying it relaxes and opens up your airways. And this is a huge advantage, making it a fantastic choice for patients who have conditions like asthma. It actually helps them breathe easier during the whole procedure. Of course, it also has effects that need to be monitored very closely.
It causes a drop in blood pressure because it relaxes your blood vessels, and it does slow down your breathing. The good news is that its effect on your heart's actual pumping ability is generally less than some other anesthetics. And all of this? This is the delicate balancing act that your anesthesiologist is managing from one moment to the next.
And that really brings us to the bigger picture, because like any powerful medication, sevoflurane isn't perfect. It has a very specific set of pros and cons that doctors have to weigh for every single patient. The advantages are all the powerful things we've been talking about. That super fast onset and recovery, the pleasant smell that's ideal for kids, how it's an excellent bronchodilator, and it's pretty good stability for your heart. But on the other side of the coin, you've got the trade-offs. It can trigger a very rare condition called malignant hyperthermia. It can sometimes cause agitation in kids as they're waking up. And then there's this thing called compound A.
So what is compound A? Well, it's a substance that gets formed when sevoflurane interacts with the carbon dioxide absorbers inside the anesthesia machine. And early on, this was a major concern because studies in rats showed it could cause kidney damage.
However, and this is the absolutely crucial context here, that risk has not really materialized in people. As this quote from our source material says, extensive studies in humans have failed to find any clinically significant kidney damage. So while precautions are still taken, that initial fear has largely been put to rest by decades of real-world evidence. So what's the bottom line here? What should you take away? Sevoflurane is an absolute pillar of modern anesthesia, and for good reason. Its defining feature is its speed, allowing for that fast induction, a nice, clear recovery. It works with that sophisticated 1-2 punch on the brain's circuitry. And yeah, while it does have risks, like any potent anesthetic, those risks are really well understood and they're expertly managed in the operating room every single day. I mean, sevoflurane's blend of speed, safety, and gentleness was a true revolution. And it just makes you wonder, right? As our understanding of the brain and medicine gets deeper and deeper, what's the next generation of anesthesia going to look like? And what new possibilities will that unlock for all of us?